I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a material so thin it's only 1 atom thick, yet 200 times stronger than steel, more conductive than copper, and lighter than air. It sounds like science fiction, right? But this is real. It's graphene, a single sheet of carbon atoms arranged in a perfect honeycomb lattice. And it's not just a laboratory wonder anymore. Graphene is quietly reshaping everything, from the phones in our pockets to the rockets that could one day take us to Mars. Since its discovery less than 2 decades ago, graphene has evolved from a scientific curiosity into one of the most strategic materials on Earth. Why? Because it does almost everything better than anything we've ever made before. It bends without breaking, it conducts electricity faster than any known material, and it's so transparent that you can barely see it, yet it's strong enough to stop a bullet. That combination makes it the ultimate hybrid: strong, light, flexible, and fast. Picture a world where batteries charge in minutes, where aircraft are lighter and more efficient, and where soldiers wear armor as thin as fabric. That's the world graphene is helping to create. We're already seeing it in flexible smartphones, wearable medical sensors, ultra-thin solar panels, and supercapacitors that could one day replace batteries entirely. At its core, graphene's magic lies in its atomic design, a single layer of carbon atoms arranged in a repeating hexagonal pattern. This structure lets electrons zip through it at incredible speeds, almost as if they're moving through a vacuum. That's why graphene is sometimes called a superhighway for electricity and heat. It's the reason scientists believe it can outperform silicon, the foundation of all modern electronics. In labs around the world, researchers are using graphene to build transistors that switch faster, circuits that use far less power, and chips that could power the next generation of AI systems and quantum computers. Samsung and Huawei have already added graphene-based cooling to their foldable phones, and MIT engineers are testing it for future 6G communication systems and terahertz imaging, the kind of technology that could revolutionize wireless networks and medical diagnostics. But the story doesn't stop at electronics. In energy technology, graphene is a game changer. Batteries that use graphene can charge up to 5 times faster than lithium-ion and last much longer. Supercapacitors made from graphene can store massive bursts of energy and deliver them instantly, powering electric vehicles that could recharge in under a minute. And because graphene is nearly transparent, it's being built into solar panels that can turn entire skyscraper windows into clean power generators. Now imagine that same material in the skies and on the battlefield. In aerospace, graphene composites are replacing traditional carbon fiber, making aircraft parts that are lighter and stronger at the same time. Airbus and Boeing are already experimenting with it for wingtips, fuselage panels, and heat-resistant components for engines. Every kilogram saved means lower fuel costs and longer flight ranges, a huge win for sustainability and performance. In defense, graphene takes things even further. It's being woven into next-generation armor that's thin, flexible, and incredibly strong, capable of absorbing impact without the weight of steel or Kevlar. Graphene-based coatings can even make military vehicles and aircraft stealthier by absorbing radar waves, and scientists are exploring graphene sensors for detecting chemical, biological, and radiological threats on the battlefield. It's the ultimate fusion of material science and defense strategy. All this progress has ignited a fierce global race. China currently leads the world in graphene production, holding more than 60% of global patents. The European Union, through its billion-euro graphene flagship project, is investing heavily in sustainable and industrial-scale innovation. The United States is focusing on advanced computing and defense, with DARPA funding research into graphene-based quantum sensors and IBM experimenting with graphene quantum bits. Meanwhile, Japan and South Korea are using it to push the limits of battery technology and high-speed electronics. Each nation knows that whoever masters graphene will have the edge in everything: energy, communications, aerospace, and even national security. It's not just a technological race, it's a strategic one. But even wonder materials face real challenges. Producing large sheets of pure, defect-free graphene is still difficult and expensive. Most commercial products today use graphene flakes mixed into composites rather than perfect single layers. However, scientists are finding new, eco-friendly methods to produce it, even from agricultural waste or coal, making it more affordable and sustainable. So while graphene hasn't yet replaced silicon or steel, it's getting closer every year. From faster computers to flexible spacecraft and sustainable batteries, it's driving a quiet revolution across industries. The real question now isn't if graphene will transform our world, it's who will get there first. One atom thick, yet powerful enough to reshake civilization. This is graphene. And as nations race to unlock its potential, the graphene revolution is just beginning. For more stories on technologies shaping the future of science, defense, and humanity, stay tuned to IDST channel, where innovation meets strategy.
Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.